Hi, welcome to the class. Today we are going to start a new topic of chapter refraction, and that is refraction of light through a glass slab. So we'll understand how the light refracts through a glass slab, and then we'll study some topics related to refraction through a prism, and then we'll continue with that. So refraction through a glass slab. So this is a glass slab. PQRS is a glass slab. So there are two refracting surfaces of this glass slab. One refracting surface is PQ. So as we discussed earlier that light is coming from air, which is a rarer medium, then it is going into the glass, which is a denser medium. So when light goes from, this is AB is the incident ray. When light go from rarer medium to denser medium, it bends towards the normal. So it is bending towards the normal. Okay. So I drew a normal here. N1 is the normal. So the angle between the normal and the incident ray is known as angle of incidence. So I1 is the angle of incidence. Then this is BC is the refracted ray. The angle between the refracted ray and the normal is known as angle of refraction. So this R is angle of refraction. Alright. Now light ray is in glass. That is in denser medium. When this will go from this denser medium, that is from glass, again to air, which is a rarer medium, it will bend away from the normal. So when light ray strikes this surface RS, since it is striking inside the glass at surface RS, so I have considered that this light ray is again falling on this surface and I am treating this BC as the incident ray inside the glass, because it is striking the surface RS. So I have taken or I have considered BC as the angle, as the ray of incidence for RS. I have considered BC as the incident ray for surface RS. That is why I have taken this angle as I2. Okay. So I1 is the angle of incidence. I1 is the angle of incidence for PQ surface. I2 is the angle of incidence for RS surface. Then light ray will go from denser, that is glass, to rarer, that is air. So it will bend away from the normal. So this CD is known as emergent ray, and this E is known as angle of emergence. So if you look here, you can see AB is the incident ray, BC refracted ray, CD which is the emergent ray which is emerging out of the glass. I1, I2 angle of incidences. I1 is the angle of incidence for surface PQ and I2 is the angle of incidence for surface RS. R angle of refraction, E angle of emergence, and N1 and N2 are two normals. One normal for the surface PQ, another normal for surface RS. What we have to keep in mind while dealing with this topic, that one should be aware of this whole diagram, and also one should understand that practically this result comes from practical. So practically angle I1, that is this angle of incidence and this angle of emergence, they are equal. It means the angle of incidence on surface PQ and the angle of emergence, they are always equal. This is practically, experimentally, you can prove this thing. Alright. One more thing, if we assume that there is no glass prism, if there was no glass prism, then how the light will move? So obviously this light will not bend anymore because there is no glass prism. So no glass prism means light will go like this. This will be the actual path of the light ray. Now we will see from the actual path of the light ray how much light has deviated or how much displacement it has done because of the glass slab. Because of this glass slab, how much displacement the light has done. So the displacement from its actual path, or the displacement between the actual path of the light ray when there was no glass slab and the emergent ray, that displacement is known as lateral displacement. This is known as lateral displacement. So one should understand, one should be able to draw the diagram when you are studying refraction through a glass slab. One should keep this thing in mind, that angle of incidence and this angle of emergence are equal. That can be proved experimentally. And this lateral displacement, to define lateral displacement. So lateral displacement is the displacement between the actual path of the light ray when there was no glass slab and the emergent ray. So the displacement between the actual light ray and the emergent ray is known as lateral displacement. Okay, so now refraction through glass slab we have done. Now refraction through a prism. We'll do next is with a prism. So this is a prism. Let us name this prism as A, B and C. This is the incident ray. Let us name it as PQ. Okay. So now, if this is PQ is the incident ray and this AB is the surface, how you will draw the normal? So you will draw the normal like this. So this will be a normal. So angle between these two will be known as I1. So I1 is the angle of incidence for surface AB. For surface AB, angle of incidence is I1. Now the light ray will bend towards the normal. So it will bend like this. Why it will bend towards the normal? Because light ray is going from rarer to denser medium. This is known as angle R. That is the angle of refraction. Now the light ray is striking on surface AC. So when it is striking on surface AC, the normal will be drawn like this. So this will be, I'm taking it as I2. Why I2? Because I am considering that light ray is striking this QR light ray. This QR light ray is striking surface AC. So I am considering QR as the incident ray, and that is why I have taken it as this thing. Now it will come, again light ray is coming from denser to rarer, it will go away from the normal. So this RS will be the emergent ray and this will be angle of emergence. Okay. Now we assume that if there was no prism, how the light ray would have gone? It would have gone straight like this if there was no prism. So we extend it backwards. So actually what we wanted to know is this, that if there was no prism, then the light ray would have gone straight, and with the prism, with the presence of the prism, it has bent like this. So actually by how much angle the light ray has actually bent from its original path. So this was the original path. So how much it has deviated from its original path, by how much angle. So this angle is known as angle of deviation, which is del. So what is del? Del is angle of deviation. Angle of deviation. So one should be able to draw this diagram to spot this angle of deviation, and this angle A is known as angle A is known as angle of prism. Okay. So one should keep this thing in mind. Now one more thing I would like to bring here is this. There is again one experimental graph which we draw. So we keep angle of deviation here, angle of incidence here. So what we have seen in experiment, that when the angle of incidence is more, let us say when the angle of incidence is less, angle of deviation is more. So when we are starting with angle of incidence, that is this angle. When we are starting with an angle of 30 degree, experimentally we do this, 30 degree, when you do it with 30 degree, angle of deviation will be more. So as you increase your angle of incidence, angle of deviation decreases up to a certain point. It decreases up to a certain point. It means with 30 degree angle of deviation will be more, with 35 it will be less as compared to 30. So as the angle of incidence increases, angle of deviation will decrease up to a certain point, and then it will start increasing again. So the graph is like this, U-shaped graph. So at this point, this is angle of incidence, and for this angle of incidence we have the minimum deviation. For this particular angle we have minimum deviation, del minimum. So one should be able to draw this diagram as well, that with this particular angle, at this particular angle we have a minimum deviation. Okay, and when you have minimum deviation, when you have this minimum deviation, we follow one equation, that is del minimum deviation is equals to 2i minus a. So this relation you should keep in mind. Minimum deviation is equals to 2i. I is the angle of incidence and a is the angle of prism. So this much you should be able to understand, that you should be able to plot this diagram. One should be able to explain that graph in this. As we increase the angle of incidence, angle of deviation decreases up to a certain point, and then again it starts increasing with the increase in angle of incidence. And you should be able to you should know this relation. Okay, so this can be used to solve the numericals as well. Thank you.